Okay, today we'll start with another part of differential equation, partial differential equation. In previous class, we have studied more about ordinary differential equations. And in ordinary differential equations, you must know the unknown is only single variable, and the known function, that means dependent variable, is also single variable. But in partial differential equations, a little bit difference. The partial differential equations will be unknown function will be more than 2, and known function also may be more than 2. So there is a little bit difference. So first of all, what is partial differential equations? Partial differential equations are those equations which contain partial derivatives, that means partial differential coefficient, independent variables and dependent variables. The dependent variables will be denoted by x and y, and in the independent variable will be x and y, and the dependent variable will be z. Then the partial differential coefficients can be written as like this. Jamon p will be partial differentiation of z with respect to x, and q, if q equals to partial differentiation of z with respect to y, that means that is the function of xy. Okay, and this is the second derivatives or partial derivatives of z with respect to x, and this is the differentiation of z, partial differentiation of z with respect to x and y. It is denoted by s, and partial differentiation, second partial differentiation of z with respect to y is denoted by t, p, q, r, s, t. Okay, so we here actually unknown variables, that means single dependent variables and independent variables are more than 1, then it will be called what? Partial differential equations. So what will be the order? The order of partial differential equations is the same as that of order of highest derivatives in coefficient in it. So order will be denoted by the the number of highest derivatives. The dimension of unknown in ordinary and partial derivatives. The ordinary differential equations unknown is a function of one variable. You have to remember it. And partial differential equations, the unknown means what? Independent variables. Unknown function is a function of multiple variables. You must remember this. So the ordinary differential equations will consist of single independent variable, and partial differential equations consist of multiple variables of independent multiple variables. So number of equations, single differential equations, system of differential equations, nth order differential equations and this is the actually classified by ordinary differential equations. So differential equations, actually there are two types. One is linear and non-linear. In the same case, partial differential equations also may be linear or non-linear. Remember it. Actually this function is linear because there is not multiplied with another function of dependent variable. Okay, there is no there is no term with multiplied with what? Multiplied with dependent variable. This is why it is called linear. And this is also non-linear because there is a function with multiplied with 1 divided by x, that means this x into x double dash. X double dash means what? Double differentiation of x with respect to known function. So this is non-linear. And partial differential equation in science and engineering, actually there are linear differential equation, linear partial differential equations and non-linear partial differential equations. But this is the actually types of linear differential equations of second order. Actually there are three types. One is Laplace equation, heat equation, wave equation, etc. Okay, so and another differential equation, Schrodinger wave equation, Navier-Stokes equation. This is also partial differential equations, which is frequently used in science and engineering. So most important partial differential equation example is Laplace. This is the second order actually. Laplace equation, heat equation, wave equation. Remember this. And another one is Schrodinger wave equation, Navier-Stokes equation, and this is used in fluid flow. And Schrodinger wave equation used in quantum mechanics, very important and of modern physics part. Quantum mechanics. This is the also partial differential equation. So second order partial differential equation can be classified into three categories. Actually we classified the conic curves. This is the actually equation of conics: x square plus b xy c plus cy square plus dx plus ey plus f equals to 0 as a ellipse, parabolic or hyperbola according to the sign of discriminant b square minus 4ac. This is the actually discriminant. Similarly, we can classify the second order partial differential. This is the standard form of second order partial differential equation. So if b square minus 4ac is less than 0, then elliptic, and b square minus 4ac discriminant equal to 0, then parabolic. If greater than 0, then it will be hyperbolic. So elliptic will be equilibrium equation, and the parabolic will be in diffusion equation, and hyperbolic will be wave equation. Remember it. So this is the actually classification of second order partial differential equation. So first of all, introduction to partial differential equation. Actually what is partial differential equation and from where? Suppose what is a partial differential equation? We have studied about ordinary differential equations. The ordinary differential equations have only one independent variable. So there are actually independent variable what? X, and dependent variable what? Y. So there are only single dependent variable and single independent variable. So it is called actually what? Ordinary differential equations. Now another differential equation, partial differential equation, have more than one independent variables. Actually there are two independent variables. One is x and other is y. So this is also unknown. That means more than one unknown function, and u is the actually dependent variable here. U depend on x and y, so use the function of xy. Okay, so this is why it is called partial differential equations. Now there is an important question for you. What is the basic difference between ordinary differential equation and partial differential equation? So write down this question, everybody. What is the difference between ordinary differential equations and partial differential equations? Now example of an ordinary differential equations. Actually we have studied more and more application about ordinary differential equations. Now we will study about the example of partial differential equation. Okay, so this is the actually hot water in a tank and a spherical ball. This is the spherical ball and in hot water. So this is the ball, a spherical ball, and the condition of this ball, that means the movement of this ball in hot water, can be determined by the partial differential equations. There is actually this is the Hughes equation. This is the called partial differential equation. Just this is, we are using this just for an example. Assumption: ball is not lumped system. Number of independent variables 4. Independent variables how many here? Actually 4. R, theta, pi, t. 4 types. So classification of second order linear differential equation. this is important for you, classification of second order linear partial differential equation. Suppose the linear differential second order linear partial differential equation. This is the standard form. A, B, C are function of x and y, and d is the function of, actually d is the function of this x, y, u del x or del u del y. That means five function. Okay, so 5 variables. This is actually maybe variables or constant. So del square u is the actually dependent variable, and x, y are the independent variable. This is why this is the standard form of linear partial differential equations. Now this will be the elliptic. We have seen before elliptic when this will be greater than 0. So parabolic, this discriminant b square minus 4ac will be 0, and hyperbolic will be less than 0. That means this can be written as if less than 0 then elliptic. Okay, and this is why this is the standard form of elliptic linear partial differential equation. Now example, del square t del x square plus del square t del y square. That means t is the function of xy. If we compare with this differential equation, then here a equals to what will be? A equals to 1 and b equals to what? That means this coefficient is absent here. So b equals to what will be? 0. And second derivatives of u with respect to y square will be what? C coefficient. So c equals to what will be? Given by 1 only. So b square minus 4ac equals to what? Minus 4. Understand? Just putting in, this is the discriminant. Discriminant means what? Nichayok. Okay, discriminant b square minus 4ac. Okay, so this is the less than 0. This is why, therefore the equation is elliptic. Remember it. Again, this is the standard form of linear partial differential equation, and suppose this is an example. Del t, capital T is the function of tx only. T is the time and x is the another unknown function or independent variable x. So there are two independent variable, one is t and other is x. Okay, so if we compare with this differential equation, a equals to k and b equals to 0, c equals to 0, d equals to what? Minus 1. D is the coefficient of this. So giving b square minus 4ac, we get actually 0. That means this is the parabolic. So if discriminant equals to 0, then the linear partial differential equation will be what? Parabolic. Remember it. And previous one what was? Elliptic if less than 0. Okay, so if we compare, suppose to find out the hyperbolic one, so if b square minus 4ac is greater than 0, then the equation is hyperbolic. If the system of differential equation, partial differential equation is like this. Suppose this is the equation, and this is the actually, if we compare with these two, a equals to what? 1, and b equals, this is the absent here, so b equals to what will be? 0 only. And this coefficient, this is then del square u del y square coefficient, so coefficient will be what? Capital C equals to what? 1 by small c square. This given b square minus 4ac equals to 0. That means what? This will be given by greater than 0. That means discriminant is greater than 0. So we can conclude that the equation is hyperbolic. So linear partial differential equations are 3 types only. One is elliptic, another is parabolic, and other is hyperbolic. I hope everybody understand well. Actually, there are different methods for forming, how to form partial differential equations. So first of all, the formation of partial differential equations. Actually, a partial differential equation can be formed by 2 methods. One method is eliminating arbitrary constants, and another method is eliminating arbitrary functions. That means there are 2 types of forming partial differential equations. Suppose an example, a method of eliminating arbitrary constants. Find the partial differential equations of all sphere whose entire whose center lie on z-axis and given by the equation this, where a and b are the being the constants. This is the actually equation of sphere, and whose center lies in what? Z-axis. This is actually three-dimensional. This y, x, y, and z variables. Understand? Now we try to form a partial differential equation for this. Suppose we have, this is the given equation, and this is number one equation, and this contains two arbitrary constants a and b. Okay, so differentiating one with respect to x, we get just partial differentiation. If we take partial differentiation with respect to x, then y and z will be termed as what? Constants. Remember it. So we will take partial differentiation of x with respect to z. Then this will be what? Twice x, and this is what will be 0. Y will be what? 0, and this will be x square formula 2x. Okay, so then the differentiation of z, partial differentiation of z with respect to x, and b square will be what? 0. So we get del z del x, we denoted with what? P. Del z del x, what will be? Like this, p. So again differentiating one with respect to y. Similarly with respect to y, this will be what? X square will be 0, and y square will be what? Twice y, and this square means what? 2 into z minus a del z del y equals to 0, and del z del y means what? Q. Okay, by notation. Now to eliminate a and b from 2 and 3, there is a constant a and there is another constant a in 3. So from equation 2 we can write z minus I equals to what? Minus x by p. Now putting these values in equation 3, we get this differential equation. This is the actually partial differential equation. Okay. Now methods for eliminating arbitrary function. Actually transforming function, we can form partial differential equation. Suppose from the partial differential equation from this, we have z equals to what? F of x square minus y square. This is the given function. Now differentiating one with respect to x and y, we get p equals to del z del x equals to just partial differentiation of this f of f dash x square minus y square. This will be where? Again differentiation of x, twice x, y square will be 0. Similarly with respect to y, partial differentiation of z with respect to y will be this. Now dividing 2 by 3. If we divide this 2 by 3, we get this. Okay, this will be cancelled. Understand? Solved. This is a del cube z. This is the third order. Remember it. What will be the order of this partial differential equation? Third order. Del cube z del x square del y. That means cos twice x plus thrice y. Now we have del cube. This is the given partial differential equation. Now integrating, just integrating with respect to x, we get on both sides. Okay, just integration with respect to x. This will be del square z del x del x. One del x will be decreases due to integration, and this equals to what will be? Cos x formula what? Cos x sine. Okay, cos x integration what? Sine x. Then dividing with the coefficient of x. Coefficient of x what? 2. This is why dividing with the coefficient of x. Then there will be integral constant. Integral constant will be a function of y. Remember it. Okay, integral constant will be what? Function of y. Again integrating with respect to x, we get again integrating with respect to x. So del x will be cancelled. So this will be only del z del y. This will be sine function what? Minus cos. Again with the dividing with the coefficient of x. That means dividing by 2, we get 4 here. So f of y will be integration x into 1 integration what? X. This y integration of again f of y dx, and again integration. This is the integral constant, another constant, and this is the function. This will be the function of y. So this can be written as this is another integration. This can be written as phi y zy. So integrating with respect to y, we get integrating with respect to y, we get only z. Okay, so z, then this is the integration, and this is the integration sign. So after integration, this will be x into phi 1 y and phi 2 y. This will be the solution of the partial differential equations. Just taking integration, differential coefficients will be decreases. There are 3 times differentiation, remember it, because third order this is y, and x square, this is the second derivative of with respect to x. This is why with respect to x, how many integration? 2 times. Similarly, del square z del x del y equals to x square y. This is another partial differential equation of second order, subject to the condition what? There is a given some conditions, initial conditions and boundary conditions, that x0 equals to what? X square, and z1y equals to cos y. This is the given differential partial differential equation. On integrating with respect to x, del x will be what? Cancelled. Just integrating. Del z del y equals to this integration what? X cube by 3. That means x to the power 2 plus 1 divided by 2 plus 1. That means x cube by 3 y. This is the constant, and this constant will be function of y. Integrating with respect to y, this del y will be cancelled. Thus z equals to x cube by 3, and this will be y square by 2. Okay, this is the function of integration of f of y. Then another integration, okay, z of x. So z equals to, this is the actually formula, solution of partial differential equation. Now condition, first putting z equals to x square and y equals to 0 in equation 1. Why? This is the z x equals to z is the function of xy. Okay, so y equals to 0 here, and x equals to what? Z equals to what? X square. Z equals to x square. So z equals to x square and y equals to 0. Then putting in this solution, we get x square equal to 0 plus f of 0 plus zx. Again, now putting the value of zx in 1 in equation 1, then we get value of zx what? This we get. Again condition, given condition z1y equals to cos y. So if x here, x equals to 1 and y and z equals to what? Cos y. If x equals to 1 and z equals to what? Cos y. Then putting it in equation 2, so cos y equals to y square by 6 plus f of y plus 1 minus f of 0. Then f of y equals to what will be? F of y what will be? Cos y minus 1 by 6. Just putting x equals to 1 here, then you get this. Now putting the value of f of y, this is the value of f of y in equation 2, we get the whole solution. This is very important question for you, example 4. Okay, Lagrange linear is an equation of the type P and here capital P into P, small p plus capital Q into small q equals to R. Actually, these types of partial differential equation is called Lagrange partial differential equation. Okay, I'm not proving this. This types of differential equation, partial differential equation is called what? Lagrange partial differential. PP capital P into small p plus capital Q into small q equals to R. Okay, how to solve this? Actually, write down the auxiliary we can write the auxiliary equation like this: dx by capital P, dy by capital Q, dz by capital R. Then solve the above auxiliary equation. Let the two equations are u and c1. Then we can form the function 0 and this. Actually, if we try to solve only one example, solve the following partial differential equation: yq minus xp equals to z, where p equals to what? Del z del x, and q equals to what? Del z del y. So you can write, we have what? yq minus xp equals to what? Z. This is the given partial differential equation. So auxiliary equation can be written as dx divided by minus x. Okay, p coefficient, and dy divided by what will be q coefficient. Okay, and dz divided by what will be right hand side. Understand? Everybody understand? Dx divided by what will be p coefficient. P coefficient what? Minus x. And dy divided by what will be q coefficient, and dz divided by r coefficient r. Okay, so one by in taking integration on both, on all sides, there are actually three sides. Okay, this is the left, this is the middle, this is the right. So taking integration, 1 by x formula what? Log x. 1 by x formula log x, 1 by x formula log x. And this is the actually from what? From first two equations we get this. Xy equals to what will be a. From the last two log y, 1 by x formula log x, 1 by z formula log z. This is the integral constant. Okay, so yz divided by b. So from equation 1 and 2 we can write f of xy. Xy is the first one and y by z is the second one. Second function, first function, second function equals to 0. This is the actual result. Understand? Just only one example here discussing. Now partial differential equation nonlinear in P and Q. Okay, but in previous we have studied about linear. Now nonlinear form. We give value the method for solving a nonlinear partial differential equation in certain standard form only. Type 1, equation of the type f of pq equals to 0. If the equation are formed like this, then z equals to what will be? X plus by plus c equals c. Then del z will be what? Partial differentiation of z with respect to x will be a, and partial differentiation of z with respect to y will be b. So solution can be written as f of b0. Now let us consider another example. Solve p square plus q square equals to 1. This is actually a non-linear partial differential equation where p equals to del z and let z equals to x plus by plus c. This is the solution of this. Okay, so here p equals to what? Del x equals to a, and q equals to what? Del z del y. Just taking partial differentiation of z with respect to y, you get b. Now substituting the values of p q in equation 1. In equation 1 we get b equals to what? 1 minus root over 1 minus s square. Now putting the value of b in equation 2 we get z equals to this. This is the actually solution. Very easy, simple. Understand everybody? Okay, another method, Charpit's method, general method for solving partial differential equation with two independent variables. This is the method is called actually Charpit's method. Let the general partial differential equation be like this. Function of what? X, y, z, and p equals to what? Partial differentiation of z with respect to x, and q will be the partial differentiation of y with of z with respect to y. This is the actual 5 unknown. So the z depends on x, y. Remember it. So dz equals to this is the by the definition of total differential equation. Total differentiation. Okay, dz equals to this. That means dz equals to p dx and q dy. The main thing in Charpit's method is to find another relation between the variables x, y, z and pq. Okay, this is actually 5 unknown here. Phi of this is the phi is the function of with 5 unknown equals to 0. Now on solving 1 and 3, this is the equation 1 and this is the 3. Okay, same unknown, but this is f and this is phi. Remember it. So this is the actually taking partial differentiation with respect to x. Okay, and this is the from 1 and 3. This is from 1 and this is from 3, taking partial differentiation with respect to x, and this is from the 3, and this is the from 1 with respect to y, and this is from 3 with respect to y. Now we can eliminating, I am not proving it, just I am talking about this. Just by Charpit's method, we will try to solve a partial differential equation. Okay. Now solve p of x equals p into x plus q into y equals to pq. Suppose this is the function of x, y, z, pq equals to 0. Is this is the given function, okay? Px plus qy minus pq equal to 0. Actually, we must know pq what was. P is the del f del x, partial differentiation of x with respect to x, and partial differentiation of f with respect to y will be what, q, and del f del z will be here in given equation 0. Okay, so del f del p will be taking partial differentiation with respect to p. Okay, x minus q. With respect to p, we'll get this. With respect to q will be y minus p from this equation 1. Now by Charpit's method, we can write this whole like this. dx divided by what? Del f del p. Del f del p, just using this relation. Dx divided by what will be? Minus del f by del p, dy divided by minus del f by del q, and dz divided by what? Pq. P del f del p minus q del f del q, and dp divided by what will be? Del f del x plus p into del f del z, and dq divided by del f del y plus q into del f del z, and in right hand side del phi divided by 0. This is the actually from what? By Charpit's method. Understand? Just comparing with this, we get minus, this is the ratio from that. So just putting these values here, just putting these values, we get this one. We choose now we have to choose the simplest integral involving p and q. This is the dp by p and dq by q. After calculation, we get this. So taking integration on both sides, we get p equals to aq. Now putting for p in the given equation 1. Given equation 1. This is the given equation, px plus qy minus pq equal to 0. Just putting p equals to aq, we get this. So q equal to y plus x divided by a, and after cross multiplication, dz equals to p dx plus q dy. Now putting for p and q in equation 2. Dz equals to what will be? P equals to what? Y plus x. Okay, p equals to y plus x, and q equals to what will be? Y plus x by a. Then we get this is the actually solution of what? Given partial differential equation by Charpit's method. This is the integration, taking integration on both sides. This integration dz will be z, and y plus x integration what will be with respect to this? Actually, this differentiation will be this. Okay, so this is the formula will be x square by 2 only. Look like x dx. This is why x dx formula what it will be? X square by 2, and this is the integral constant. Now actually linear partial differential equation with constant coefficient of second order. In ordinary differential equation, we have studied about the constant coefficient method. Actually in linear homogeneous partial differential equations of nth order with constant coefficient, this will be the actually z is the function of xy. Okay, z is the function of xy. Then if the equation is this types, then it's called homogeneous linear partial differential equation of nth order with constant coefficient, and it is called homogeneous because all the term contains derivative of the same order. Same order. This is the nth order, this is nth order, this is nth order. This is why this is called homogeneous partial differential equations. Actually there are many rules for finding solution for that. Suppose this is the partial differential equations. Okay, d cube minus 4d square d dash plus 3d d dash whole square into z equals to 0, where capital if we take you know if we take the auxiliary equation, okay, left hand side equals to 0, then z equals to e to the power mx, okay. Its auxiliary equation will be for d cube, what will be m cube minus 4m square plus thrice m equals to 0. Just for solving m equals to 0, 1, 2, 3, then the required solution can be written as a partial form. Z equals to what? f1 y plus f2 y plus x, f3 y plus thrice x. Okay, this will be the required solution. Similarly, for you can solve this. Suppose example 3. This is the fourth order partial differential equation, linear partial differential equation, and this is also homogeneous. Okay, order same in every term. So this is the auxiliary equation. Okay, here capital D equals to what? Del x. Okay, capital D equals to, and d dash, capital D dash will be del y. Okay, so auxiliary equation can be written as m4 2m cube plus twice m minus 1, okay, equal to 0. After solving, we get 3 repeated roots. 3 repeated roots shows that equals to can be written as f of 1 y minus x. This is the minus x, okay, y minus x. This is the y plus x, y plus x, y plus x. And for repeated roots, we must know first repeated roots y plus x, and then x into, and then x square into. Okay, the partial the solution of the partial differential equations can be written as like this. This is the table for roots. For different roots, we can write y plus m1x plus f of 2, y plus m2x plus f of 3, y plus m3x. This is the complementary function. That means solution of auxiliary equation. Understand? Then for 2 repeated roots can be written as like this. You have to multiply y plus m1x, x into y plus m1x. Remember it. For 3 repeated roots, we can write y plus m1x, x into y plus f2, y plus m1x, x square into f3, y plus m1x. Understand? This is the rules for writing complementary function for partial differential equations, and of course for homogeneous, linear homogeneous partial differential equations with constant coefficient. Remember it. Actually, after solve the linear partial differential equation, this can be written as d4 plus d dash 4. Okay, z. Then auxiliary equation will be m4 plus 1 equals to 0. After solving this, then we get, actually there are how many roots? So these 4 roots here, because this is the fourth order partial differential equations. So this the solution can be written as f1 y plus m1x plus f2 y plus m2x, f3 y plus m3x, f4 plus y plus m4x. This is the solution. Okay, now application of partial differential equations. In applied mathematics, the partial differential equations generally arise from the mathematical formulation of physical problem subject to certain given conditions called boundary conditions. Solving such as an equation is known as solving a boundary value problem. That means in partial differential equations, some conditions are given with partially, or this is also called initial value Maybe initial values are some given, then the equation will be initial value problem. The problem will be initial value problem, and if boundary conditions are given, then that will be boundary value problem. The method of solving such equations differs from the that used in the case of ordinary differential equations. In ordinary differential equations, we used various methods, but a little bit difference. There is a little bit difference with that. We first find out the general solution of the ordinary differential equations and determine the particular solution with the help of given conditions. Here from the start, we try to find out the particular solution of the partial differential equation which satisfy all the boundary conditions. So method of separation of variables is employed here. Actually, we are trying to solve a partial differential equations by applying what? By applying method of separation of variables, right? Method of separation of variables. In this method, we assume that the dependent variable is the product of two functions. Dependent variable what will be product of two functions, each function which involves only one of the independent variable. So the ordinary differential equations are formed. Understand? Now example 1, apply the method of separation of variables techniques, find the solution to the partial differential equations. 3 into ux, this is the u is the function of first differentiation of u with respect to x, okay, plus 2 into uy equals to 0, where ux equals to what? Del u del x, and uy equals to what will be? Del u del y, partial differential coefficient here. So the given partial differential equation can be written as like this: 3 into del u del x plus 2 into del u del y equals to 0. Now let us consider the solution of this. This is the u is the actually dependent variable here, and u is the function of x y here, okay. So u depend on x and y. So x and y are the independent variable and u is the dependent variable, okay. Now let us consider the solution of this differential equations. U equals to capital X and capital Y. Capital X is the function of x and capital Y is the function of y. In every where we have to let us consider these types of solution for the differential equation. Understand? Actually, in variable separable method, we first of all we will consider u equals to what? X y, okay, and capital X is the function of x and capital Y is the function of small y only. So on differentiating equation 2 partially with respect to x, taking partial differentiation of u with respect to x, del u del x, what will be? Del x by del x, and this will be y, only y, okay. That means just we are taking partial differentiation of u with respect to x on both sides, okay. So del u del x will be what? Capital X del x del capital X del x into only y. Y is the function of small y. Now again on differentiating 2 with respect to y, similar process. Del u del y equals to what will be? X into del y del capital Y divided by del y, okay. Now putting the values of this in equation 3 and 4, just putting this value and this value in equation 1. So we get only 3 del x del capital X by del x into y plus 2 capital X del capital Y divided by del y equals to 0. Now dividing 5 by xy, dividing by xy on both sides, understand? Then we get this differential equation will be the form like this. Right hand side is constant for left hand side, so we take both equation are equal to k constant. Actually after dividing by xy we get this. Then this can be written as 3 by x del x del x by capital X equals to this minus this, okay. Now this is the ratio. Actually this ratio equals to this ratio equals to k. Taking a constant k, this ratio will be k. So first one equals to k and second one equals to also k. So this can be written as what? Del x by x equals to k by 3 into del x by variable separable method. Understand? Multiplying by what? Del x on both sides and dividing by 3 on both sides. From this we get. And again this can be written as this, just variable separable, capital Y in one's left hand side and small and other constant will be in right hand side. Okay, now from these two we can write just taking integration on both sides. 1 by x formula what? Log x, k by 3 x. Okay, so del x will be only x, and this is the c1 is the what? Integral constant. Now from this second one, 1 by y formula log y equals to minus k by 3 only small y plus c2 is the integral constant for the second ratios. So this solution can be written as capital X equals to what? Exponential, taking exponentiation on both sides. E to the power, this will be whole power of e. Okay, similarly y equals to e to the power this. Understand? Now putting the values of x and y in equation 2. Equation 2, which one? This one. This is the solution or our solution. U equals to what was? Xy. So just putting the value of xy, u equals to what will be? X into y, and e is the base. So taking same base, then power will be add k into x by 3 minus y by 3 plus c1 plus c2. So this can be separated with what? E to the power k into x by 3 minus c by 3 and e to the power c1 plus c2. This is another constant. Understand? This is another constant. So u can be written as capital I into e to the power k into x by 3 minus y by 3. This is the solution of the given partial differential equation by variable separable method. Now example 2, solve the following equation, del square z by del x square minus 2 del z del x plus del z del y equals to 0 by the method of separation of variables. Okay, given equation is this, del square z, this is the given equation. Now let us consider z equals to what? Xy. Okay, in previous u was the dependent variable, but here z is the dependent variable. This is why consider solution z equals to what? Xy. Similarly, x is the function of small x and capital Y is the function of small y only. So we can take partial differentiation of z with respect to x will be this, and double differentiation what will be? Del square z by del x square will be y into what? Y into d square x by dx square. Understand? So similarly del z del y equals to capital X into dy dy. Now putting all these values in equation 1, just substituting these values in equation 1, we get this. Okay, now dividing by xy on both sides, same process, same procedure. Okay, so this minus this plus this equals to 0. Now separating variables, we get 1 by capital X d square x by dx square minus 2 by x dx by dx equals to what? This is the y variable, right hand side, minus this equals to k. Let now first part equals to k and second part equals to k. Right hand side equals to k. This is the left hand side equals to k. Now this is the ordinary differential equation, d square, just multiplying x on both sides, so we get this, and this is the d square minus 2d plus minus k into x equals to 0. This is the ordinary differential equation with constant coefficient. Understand? So auxiliary equation will be what? M square minus twice m minus k equals to 0. So m equals to complex roots. Two complex roots. The solution x can be written as c1 e to the power 1 plus this x m1x c2 e to the power m2x. m2 means what? Negative 1. 1 minus root over 1 plus k. Now for another one, this is also ordinary differential equation with constant coefficients. This can be written as d plus k, and auxiliary equation will be what? M plus k equals to 0. M equals to what? minus k. So y what will be? C3 e to the power mx. M means what? Minus k e to the. So there are three constant. So the putting the values of x, y in equation 3 and 4. That means this equation gives the solution. Just putting the value of x, y. Very easy for you. If you understand only one maths, you can solve. Now example 3, using the method of separation of variables, solve this, where u into x0 equals to 6 e to the power minus 3x. Very important for you. Important question. Del u del x equals to 2 into del u del t plus u. This is the partial differential equation of u with respect to what? X and t. X and t is the independent variable here, and u is the dependent variable. And this is the initial condition given. Suppose this is the given differential equation, and let us consider this will be the solution. U equal to x and t. There are the capital X and capital T, because the small t is the dependent variable. Now putting so capital X is the function of small x and capital T is the function of small t only. So putting the value of u in equation 1. Just putting the value of u in equation 1, we get this. This is the actually the capital T is the constant here when we take del x, and capital T is the capital X is the constant here, because this is the partial differential coefficient. So you can write this. Understand? Now on separating variable, we can write this equals to this minus this equals to this equals to c. First one equals to c and second one equals to c. Then this is the differential coefficient with ordinary differential equation with constant coefficient. So auxiliary equation will be minus c for the trial solution e to the power mx. So x equals to what will be a into e to the power mx. M means what? Constant only. E to the power m means what? Only c. Again, for the right one, dt minus this is the constant one. So auxiliary equation will be m minus this equal to 0, m equals to what will be this. So capital T equals to b into e to the power mx. M means what? This. At x will be what? T, because with respect to small t. Now putting the value of x and t, we get the required solution. A required solution equals to this. Now on putting t equals to 0, u equals to this. This is the given condition. Initial condition what? T equals to 0 here. U is the function of xt. Understand? U is the function of xt. Here t equals to 0. Then u equals to what will be? This one. If t equals to 0, then u equals to 6 into e to the power minus 3x. So on putting t equals to 0, u equals to what? 6 into e to the power minus 3x in equation 3. This is the solution. So u equals to this, ab e to the power what? T equals to 0. This is why e to the power cx. This whole term will be 0. E to the power cx. Here ab equals to 6, equating on both sides. Equating on both sides, taking equal on both sides. ab equals to what? 6. And minus thrice x equals to what? Cx. So c equals to what? Minus 3. Now putting the value of ab and c in equation 3, we get this. This is the required solution. Very important for you. Now solve the following equation by the method of separation of variables. Use the condition, initial condition equals to 0 and t equals to 0, and del u del t equals to 0 when x equals to 0. So this is the given partial differential equation. Let capital X be the function of x and capital T is the function of small t, and u is the xt is the solution of this partial differential equation. Now taking partial differentiation of u with respect to small t will be this, and with respect to double differentiation of this with respect to x, del x, taking del x on both sides. Okay, taking del x on both sides, we get this and this same. Okay, so del x of this will be what? X into dt. So this can be written as what? This can be written as dt divided by small t x dx divided by dx. So substituting these values, from equation 2, then we get this. This is the given differential equation. Can take the form this. Okay. Now separating the variable, we get dividing by both sides on e to the power t minus t. That means multiplying e to the power t on both sides. This will be cancelled, and dividing with this, making variable separable. T variable left hand side and x variable in right hand side. This equals to what? Minus p square. Say we have considered this minus p square. This may be other variable, capital k. You can consider k square also, minus k square also. So this equal to this one, and this equals to this one here. So just solving, dt equals to what will be? Minus p square into e to the power minus t, and this can be written as dx equals to what? This multiply a small dx. Now on integrating on both sides, capital T equals to what will be? P square e to the power x formula, e to the power x. Okay, just multiply dividing with the coefficient of t. Coefficient of t what? Minus 1. Minus 1 minus 1 will be cancelled. C1. Now on integrated, capital X equals to the cos x integration what? Sin x. Cos x integration what? Sin x. This C2 is the constant. Just putting the value of tx on this. Okay, in equation 1 we get this one. Now putting u equals to 0 when t equals to 0, u equals to 0 and t equals to 0. T equals to 0 here, this into p square e to the power 0 means 1. This. So from this we get p square plus c1 equals to 0. So c1 equals to what? Minus p square. Again differentiating 6 with respect to t. Why? Just putting this value. Putting this value, we have to differentiate u with respect to t. Understand? So from 6, taking differentiation du dt, del u del t will be what? This is the constant p square e to the power t formula, e to the power t. Dividing with the coefficient of what? T. That means dividing with the coefficient of minus 1. Then minus 1. Dividing with the coefficient of minus 1. So we get this one. Now again imposing the initial condition del u del t equals to 0 when x equals to 0. This is given condition. So del u del t is equal to 0 when x equals to 0. X equals to 0 means what? Sin 0 means whole 0. Okay. So C2 into this. C2 into this one. So C2 equals to what will be actually? This is e to the power something can never be 0. E to the power something means what? Any real number can never be 0. So C1 will be, C2 will be 0, and C1 equals to minus p square and C2 equals to 0. Just putting in this solution. This is the solution. Okay. Putting C1 equals to minus p square and C2 equals to what? 0. We get the required solution. This. Okay. Similarly, 5 examples will be 5 will be homework for you, and you will try to solve 1, 2, 3 only 1, 2, 3 only 1, 2 and 3. One-dimensional heat equation. Okay, how to solve the heat equation? Solve the method of separation of variables. Solve the partial differential equation. This is the actually heat equation. Okay, how to solve heat equation? Same procedure. Here this is the given one-dimensional heat equation. Suppose here u is the function of tx. Okay, so let us consider the solution will be u equals to what? Xt. Similar process, we have solved these types of differential equations. Now taking differentiation, partial differentiation of u with respect to t, we get this, and double differentiation of what will be? Del square u del x square, what will be? C square del square del x square xt. Then we get this one. Now putting these two values in the given partial differential equation 1, we get this. Now taking variable separable, we can write dt by what? Capital T, and this divided by capital X. Now left hand side is constant for x. We can take this minus p square. Right hand side also minus p square. Just taking same constant. This equals to minus p square, this equals to minus p square. So first part equals to minus p square and second part equals to minus p square. Solving auxiliary equation what? M equals to this. So capital T equal to C1 e to the power minus c square p square t. This into t. And auxiliary for this second one, auxiliary equation will be m square equal to what? Minus p square. So m equals to I minus 1 equals to what? I square. So this is the complex roots. This can be written as CO2 cos px, and C3 sin px for complex roots of this ordinary differential equation. Now putting the value of t and x, we get the required solution. Now example 16, find the temperature in a bar of length 2 whose ends kept at 0 and lateral surface insulated if the initial temperature is this. Okay, now here we have one-dimensional heat flow equation, this one-dimensional heat flow equation. You have to remember this heat equation, del u double t equal to c square del square u del x square. Now its solution you must know from this. Okay, this is the solution of this. C1 cos px plus C3 sin px, C3 into this. You can change the constant. Now putting x equals to 0, u equals to 0 in equation 1. Why? The ends keep at 0. Okay, so length will be 0, x equals to 0, y equals to 0. Putting here, we get C1 equals to what? 0. Now putting C1 equals to 0 in equation 1, we get C2 into this. Okay, u equals to this will be. Again putting x equals to 2 and u equals to 0. So the lateral surface isolated, find the temperature in a bar of length 2. So if x equals to 2, then means length 2, then u equals to what will be? 0 in equation 2. Now u equals to 0 and x equals to what will be? 2 only. So this can be written as sin twice p equals to e to the power, sin twice p equals to what will be? 0. And 0 means what? Sin n pi. So p can be written as n pi by 2, right? Understand? P equals to n pi by 2, where n is the belongs to I, integer. Now putting the value of p in equation 2, we get u equals to bn. This is the whole constant. C2, C3 will be bn, and sin p equals to what? P equals to n pi by 2. Sin n pi x by 2 e to the power minus c square n square pi square by 4. Just putting this p value. Okay, square. So u equals to this will be the general solution. Understand? There is no constant. This is why it is called general solution of the partial differential equation of one-dimensional heat equation. Remember it. Now again, putting t equals to 0, u equals to what will be? This is the given another. The lateral surface is insulated if the initial temperature is this. Okay, now putting t equals to 0 and u equals to what will be? This in equation 3. So u equals to this, and putting t equals to 0, we get from this t equals to 0, e to the power 0 means what? 1. This why this is only. Now this can be written as up to infinite series, b1, b2, b3, b5 dot dot. Okay, on equating the coefficient of both sides, we get what? b1 equals to 5x by b1 equals to 1 and b2 equals to 3. Okay, b1 equals to 1 and this is the 5 5x by 2, 5x by 2. So b5 equals to what will be? 3. Understand? Now putting the values of b1 and b5 in equation 4, we get the equation u equals to this. Understand? Just b1 values this and b2 values this. From this is the main general solution. After putting b1 and b1 into this plus b5 into this, other will be 0. Okay. 15, 16, most important. 15 and 16 related question. Okay, note down please. 17 will be homework for you for the heat equation. The boundary conditions are given. This is the solution we have solved by variable separable method. Just imposing the same conditions. This is the general solution of this. So 15, 16, 17.
স্যার আপনার মাইক্রোফোন তো মিউট আছে।
Okay, this is the two-dimensional heat equation. Okay, two-dimensional heat equation. Now consider the heat flow in metal plate of uniform thickness in the direction parallel to the length of breadth and plate. This is the actually plate. Here are 4 points A, B, C, D. Okay, so A is the actually coordinate xy and B point coordinate x del x, just increasing del x along x axis, x del x, and at C point increase will be what, along x axis del x, and along y axis will be y del y, and at D point the increase will be y del y. Okay, and x will be the steady. So at let u be the temperature at xy at the plate at time t is given by what, del u del t, rate of change of u with respect to time t will be given c square into this. Now in steady state u does not change. That means in steady state u does not change with t, del u del t will be 0, so it becomes this equals to 0, and this is called Laplace equation in two dimension. Understand? So heat equation becomes Laplace differential equation, and this is also partial differential equations, remember it. So at steady state of u, two-dimensional heat equation becomes what? Laplace differential equation. Now we'll try to solve this Laplace equation, differential equation, partial differential equation by variable separable method. Now let us consider u be the solution xy. Okay, now now taking double differentiation del square u del x square and del square u del y square from this and putting this here, we get x y double dash plus x into y double dash, x double dash y plus x y double dash equals to 0. Taking double differentiation, this means what? This means del square u del x, putting the value from here. Okay, then we get this one. So this can be written as by variable separable method, x double dash by x, y double dash by capital Y equals to minus p square, remember it. So first part equals to this will be this, and second part equals to this will be this. Just solving, this is the ordinary differential equation. This become ordinary differential equations with constant coefficient. So so there are roots will be complex roots, m equals to plus minus p, and here also complex roots. So this can be written as c1 cos px, c2 sin px, and this will be c3 e to the power py, c4 e to the power py, because capital Y is the function of y. Okay, so and capital X is the function of x, this is y, here x, and here y, capital Y is the function of y, this is y. So putting the value of x and y in equation 2, you use this is the solution. Now putting x equals to 0, y equals to 0, u equals to 0, from where putting x equals to 0, then u equals to what, 0, using this condition. So putting x equals to 0, u equals to 0 in equation 4, then c1 equals to 0 will be again 4 reduced to, after putting c1 equals to 0, c2 into this. Okay, now on putting x equals to L, u equals to 0, by using same condition, x equals to L, then u equals to what, 0. So we get this one, c2 equals does not equals to 0. Since c2 is does not equals to 0, so sine this will be 0, equal to sine phi, same as the previous example. So p equals to what will be, n pi L. Now from 5, this 5 can be written as putting value of p, u equals to this. Again putting u equals to 0 and y equals to 0 in equation 6. X equals u equals to 0 and y equals to 0. Y equals to 0 here. Y equals to 0. Okay, y equals to 0 here. So when y equals to 0, u equals to what, 0. Using this condition, u equals to 0, y equals to 0 in equation 6. So y equals to 0, e to the power 0, e to the power 0 will be c3 plus c4 only. E to the power 0 means 1. This is why. So this can be written as c3 plus c4 equals to 0, because this is not equal to 0. So c3 equals to minus c4. Now again equation 5 becomes equals to what will be, minus c4. So we can write this, taking c3 common, c4 equals to c3, then taking c3 common. On putting y equals to a, u equals to what will be, sine n phi x by L. On putting y equals to a, y. On putting y equals to a, u equals to what will be this. This is another boundary condition. So u equals to a, sine, u equals to what will be this. Putting these values, on putting u equals to y equals to a, u equals to this in equation 7. Okay, u equals to this, and c2 c3 sine and phi x by e to the power y equals to what will be, a. So c3 c2 c3 will be what, 1 divided by this one. Okay, so putting these values in equation 7, it's actually equating the coefficient, understand, equating the coefficient we get, dividing by this on both sides. Okay, then equating the coefficient we get c2 c3 equals to what, 1 by this. So putting this in equation 7, c2 c3 will be removed, so all constants are removed. This is the actually particular general solution. You try it at home. I hope everybody can do this. Just only one example. Solve the Laplace equation. Actually, you have solved this just in previous example. Solve the Laplace equation using the same condition. A little bit difference in conditions. Okay, try it at home. Understand, everybody? This will be homework for you. Understand? Okay, bye for today. Thanks to everybody.
Assalamu alaikum, sir.
Walaikum Assalam.